Gold plating is used on copper conductors because although it's lower in conductivity than copper, it's extremely resistant to corrosion. In addition, it acts as a solid lubricant to enhance the sliding of electrical parts. It's possible to do electroplating very selectively. Just one connector finger, for example, or the complete edge connector at one time. A portable swab plating system, such as this one, can be used. It consists of a DC power supply that provides the proper plating voltages, individual swabs for each solution, conductive adhesive copper tape, and plater stop-off tape, and color-coded cables to connect the power supply with the swabs. In theory, it's based on pure electrodeposition. In practice, it's really a very simple process.
On this piece of copper clad, we'll see each of the steps in the plating process. The solutions to be used are electroclean, nickel, and gold, and they're put on with 3 swabs, each one labeled to identify the proper solution. The cathode or negative electrode is attached to the work, the anode or positive electrode to the swab, and both are connected to a power source for current. The first step is cleaning the surface with solvent to remove greases and oils. Then the electrocleaning solution is swabbed on at the proper voltage. This removes any remaining oxides and creates a virgin copper surface. After a water rinse, you can see the difference. Next comes the nickel solution. This provides the underplating or lock-off between the copper and the gold overplate. Another rinse and we're ready for the gold, providing high conductivity and lubricity. Now let's watch this process applied to a printed circuit board. This one is going to need all its connector fingers replated. Repair starts by abrading the surface down to the bare copper. However, if solder has been splashed on the fingers, it must be removed by the proper desoldering technique before the abrading is done. Next, a thorough solvent cleaning. Remember, perfect cleaning is the prime requisite for good plating. The 3 inert electrodes are then prepared with cotton to become swab anodes. A separate one is used for each solution to avoid contamination. Anode and cathode leads are plugged into the power supply, and voltage is set for each solution. These might vary from plating system to system, so be sure to check the manufacturer's instructions. The preparation of the board is simple. A piece of copper tape is used. It serves as a press-on electrode that straps across all of the contacts to be plated. Pressing it down well ensures a good connection. A good idea is to check the continuity between each lead and the tape using an ohm meter or continuity tester. The contacts are then made electrically negative by clipping on the cathode lead from the power supply. The positive lead is then attached to the first swab anode, which has been dipped in the electrocleaning solution. The procedure is to first completely wet or strike the entire surface prior to applying current. The swab should always be kept moving in a circular pattern to permit uniform coverage without burning or discoloring. This will remove the remaining oxides from the surface. The area is then thoroughly water rinsed to prepare it for the next step, the nickel underplating done with the second solution. Again, completely wet the entire area with solution prior to applying current. Then completely rinse the area with water. And now comes the gold, completely wetting first before the current is applied. It provides corrosion resistance and natural lubricating qualities. The area gets a final water rinse, and the plating tape is removed. The result? A factory-quality plating job that's been done rapidly in the field. If only a single connector finger needs to be replated, it can be done with a small pin attached to the cathode and placed on the edge of the lead. The rest of the process is the same. After the newly plated parts are clean and dry, the plating should be tested to be sure it has adhered well to the underlying copper. A piece of cellophane tape is used. Press down firmly over the plated area. When it's a static sensitive board, leave the ground strap on and later dispose of the tape properly. The test is made by rapidly pulling off the tape and closely examining both the tape and plate. In this case, the plating did not properly adhere to one of the fingers, so it will have to be redone.
In plating, remember that plating thickness is a function of time, work area, swabbing speed, swab contact area, density of the plating solution, and the amount of electrical current. The information you will need to meet your own plating thickness specifications can probably be found in the operating manual for your particular plating equipment.
You'll find a full presentation of what we've covered in your handbook, so we'll stop now. Your instructor will want to review the material with you, and in the notes section of the handbook, have you write in the particular specifications, standards, and practices of your organization. Then we'll move to our next lesson, electrical damage.